Hey, it's Masaki from the Anza Competitive Programming Club, and I'm going to be discussing the problems from last Friday's practice contest. So problem A was 7 wonders, and this is a very basic type of problem where you have to try to get what you're trying to accomplish within the question prompt and kind of determine what you need to do. So this is kind of comprehension of the problem, reading it carefully, and then it ends up being, so you get a string with certain characters and you get T, C, and G, and you have to count the number of T's, the number of C's, the number of G's, and using this formula, kind of T squared plus C squared plus G squared, and then some multiple of 7, add those together, and get the points, and then output the points. So first thing to do is to check what you know already and try it out. So in the first problem, you know this is the same as the question prompt. So there's 3 T's, 2 C's, and 1 G. And then you can create one set of T, C, and G, but you can't create a second set. And at first, I thought when approaching this problem, if you have a T, C, and a G, then you add 7. But looking at the second example, 2 squared plus 2 squared plus 2 squared with 2 T's, 2 C's, and 2 G's plus 7 didn't end up being 26. So this is 4 times 3, 12, plus 7 is equal to 19. And 19, it's missing 7, so through that, if you just check the math, then you can tell that you need, instead of checking for one set of T, C's, and G's, you have to get a multiple of 7. So how many sets of T, C's, and G's, combinations of all 3 can you create? And then to do that, you have to find the minimum of T, C, and G. So you can get the minimum T, C, G times 7, and then add it to T squared plus C squared plus G squared. And so here's a code. And in this, I ended up using a vector, pretty much like an array instead, and adding the count. And this lets me iterate through the numbers and add it in one go, but you can just use an integer T, integer C, and then increment for each one. And then do 3, but having a loop also works. So this is an alternative way to do it. And another common way, if you're just counting the numbers of T's, like if you're counting the number of a specific character, then another common way to do it would be vector of int count of size 26. And then you would do within the loop, another common way of counting would be count of C minus A plus plus. And then what this does is if the character is A, then it'll increment array count of 0. If it's B, it'll minus the character B, A would be, you get 1. So you increment the 1 within the array. So that's another common way. If it's not T, C's, and G's, and you have to do every single character, then that's another common pattern that you'll see, and stuff like that. So that might be a variation of this type of problem. This is mainly comprehension, and then looking over the sample inputs and just checking your answer and finding the multiple of 7. Another important thing is that you have to find, and I ended up doing the minimum in this way. I incremented through the thing, but you can also do main count is equal to the min of like T and min of C, G or something. G or something like that. Oh, my keyboard's acting up, but you could also do something like that if you're using T, C, and G as the variables. For number 2, problem B, joint jog jam. this one you get some integer inputs, and these correspond with the starting position of carry, Ola, carry, ending position of carry, ending position of Ola, but each position is x and y, so you get 2 for each one. And so you can either store it in pairs of integers, you can have like 8 total variables instead, whatever works. And then for here, it's important to see that, so you have a coordinate and you have an xy, starting xy, you have a starting xy, you have an ending xy, you have an ending xy, and then there are a couple possibilities. So either you move away, so let's say these two lines are moving away from each other. Then if they're moving away from each other, then the final position is going to be the furthest. If they're moving kind of towards each other and they cross at some point, then it might be here, it might be the starting distance, and it might be the ending distance, depending on what timing they cross. It might be like this, and then in this case, maybe it's the ending distance that's further. And if it's going in a different direction, then the ending position is going to be the furthest position along. But in every case, you just have to check the starting positions and the ending positions and finding this Euclidean distance. The Euclidean distance, which is just use the Pythagorean formula, a squared plus b squared is equal to c squared. So c is equal to the square root of a squared plus b squared. So this distance is going to be x1 minus x2 squared and x1 y1 minus y2 squared. Add those together and then take the square root. It's kind of messy, but it's the formula for this distance. So if you think about it like a triangle, but yeah, and that's going to be a formula for the distance. And this is kind of a lot, but basically it's taking the difference between the x values and then squaring it. I'm using the power function. Instead of multiplying it together, I'm using power of 2 to square it. And then these are the second values, squaring it, and then taking the square root of the whole thing. So this is just using the Euclidean distance formula. So this one was about trying to figure out what is going to be, trying to figure out, if you draw a picture, that might help with trying to figure it out. And you can also look at the answers and kind of guess from there as well. So the first sample input, this is actually square root of 2, and then this is actually square root of 5. So so I personally looked at the 1.414 and it looked familiar, so I knew it was square root of 2. And then this one I didn't know off the top of my head, but I tried squaring this number and got around 5. So I knew that maybe I'm taking the square root, and this is talking about distance. So I was able to kind of guess from there, guess and check. And you can try to approach the problem like that as well. And yeah, so try to look at the inputs and try to figure it out. You can reverse engineer it as well. Or you can think about it, kind of try different things and kind of guess, in what situation would the distance be further away? When would it be closer? So you can approach it in that way. Problem C is hot hike. So you go on a hike and you want to hike for a day, you want to rest for a day, and then you want to hike again. And it's very hot, so you want to minimize the maximum temperature during the 2 hiking days. So it ends up being that you hike, and then you rest, and then you hike, and then you find the maximum between day 1 and day 2, hike 1 and hike 2. You want h1, h2. You want to take the minimum of all those values. And so let's say it's 23, 27, 31, 28, 30. Then you can either start on this day and hike on 23, 31. You can start on this day and hike on this day and this day. Or you can start on this day, you can hike day 1, day 3. So stuff like that. But if you try to hike here, then you don't have a second day to hike. So the final day that you can hike is going to be, so if this is 0 and this is n-1, day n-1, then this is going to be day n-3. So that's going to be the final day that you can try it. And you can just go through it linearly and check the maximum between the two hiking days. Just skip a number and compare the values. And then the next part that you need to be careful is minimization, maximization. So you do need to be careful about that part. So input the temperatures, and then I start with, we're trying to find you want to minimize the maximum temperature, which means on the outside, we're trying to minimize. So we start with default infinity, and then for the day, we want to maximize. And so we want to start from day 0. If you 0 index the days and keep on checking day 0 and day start and day start plus 2. So start plus 1 would be here. Start plus 2 would be 2 days later with 1 rest day in between. So want to take the maximum between these temperatures, the minimum between, so we want to minimize the maximum temperature. And to do that, just check if this current maximum is less than what you have outside, and then write down the day. But this day is 0 indexed, whereas to output, you don't put day 0, you put day 1 for if you start on day 1. So do it like that, and then you'd want to output the day plus the best temperature. So just make sure you're doing that check at the end. It should be pretty straightforward. Problem D was shopping list. So here we have a bunch of strings, and there's n and m, the number of items on each of the lists, and the number of shopping lists. So you have n shopping lists, in this case 4 shopping lists, and then you have m items in each shopping list. And then you need to figure out which items are in every single shopping list. So what does everyone want to buy? And so what should immediately come to mind is you have a bunch of strings and you need to count the frequency of strings or something. It might depend on the frequency of strings or something. So this should tell you that it's maybe something like a set or a map. These might come in handy. The data structure set or map should come to mind when you're trying to use a bunch of strings and trying to map values to strings. Then you want to use a map. So the first thing that comes to mind might be, okay, so we want to map a string to an integer, and then for each shopping list, if it appears in the shopping list, increment the integer, and then at the end, count if it's equal to n. So let's say bread. So if the count for bread is 4 or something, then I want to print it out or add it to the list of solutions. And this does work to an extent, except in the question prompt, we're not actually given that each of the m items are unique items. So you could buy bread twice in the same shopping list, and then someone else could not have bread, and you would still have the possibility of having n items, and that wouldn't fulfill the condition that the number of items that are found on every list. So yeah. So what are ways of getting through that? One way to do it would be to only check after you increment into the map, then you might add that value into a set. So, or you can have a set. Instead of using a map, you can use a set and have the next set. So so first I'll explain how I did it. So let's say you have, write down this. So you have bread, carrots, cheese, eggs, and milk. First, you start with this, and then the second one, milk. Milk is in here, so it's within the set. It exists, so I write down milk in the new set. Carrots. Carrots is in the, I guess this is carrots. So carrots is good, so carrots. Bread. Bread is in here, so bread. Add it to the second list, and then pasta. Pasta wasn't in here, so I don't add it. And then yogurt. Yogurt wasn't in here, so now this is now all. So every time you add a new list, it limits. For example, even if everyone else has cheese and eggs, it'll still not fulfill. It still won't fulfill the condition. So now we can work off of the second set, and then milk, carrots, and bread are the only possible solutions to what we have. So corn isn't in there. Bread is in there. So now the new set would contain bread. Kale is not in there. Spinach is not in there. Carrots is in there. So carrots. And now, because milk wasn't in the third list, then milk will not be available even if everyone else has milk. At least one person does not have milk. So now cross this out, use this set now. And so milk, don't have. Bread we do have. So bread, cheese, carrots we do have. And yogurt we don't have in this set. So now you know that bread and carrots are it, and you print out the number of items here, and then print it out in sorted order. So I used the first set and a second set. And then kind of swap the current set with the next set. So once we use the previous set, we don't need it anymore. So I just replace it with the new set that we worked with. And the new set is what we work off of and check off of now. And to replace the previous set with the new set, I use move semantics just to make the copying, just so you don't have to copy, but it's not a huge deal. And then sets in C++ this is a tree set. So this is in sorted order. So I just output the size of the set, the final set, and then print out everything, every string in the set because it's already in order. And I also know that there's no duplicates because it's a set. So this just works a very clean way. But alternative way would be to do something like have a map and then have a set within the thing, and if you don't have it within this local set, then you would increment within the map. So the first method of doing it, having a map with string int and just counting the frequency of like bread, for example. But if you have bread twice, then you only want to count it the first time. So you count it the first time, add it to the local set to mark that you already added it to the map, and then the second time through you wouldn't add it to the map. You wouldn't increment that. Or you could have the local set and then add every item to the set, and then at the end just iterate over everything in the set and increment once. Maybe that would be so what you might do is for this section you can have a map, a string, int, map, and then for int I equals 0, I is equal less than n, I plus plus, for int j equals 0, j is less than m, j plus plus, string as. So you input in a string, and you could have a set of string, I'll just do s, and s dot insert s. And so now we get a maximum of 1 of every item in the thing, in the grocery list, and then for every string in the set, map of s plus plus, and then for every item comma count in the map, if count is equal to n, I want to print out the item name or something. But actually, you would have to print out the count. You'd have to print out the number of correct answers first. So vector of string answer something, answer dot push back, the item, the name of the item, and then maybe print out answer dot size, new line, and then for every item in answer, print out the item. So this should work as well. Yeah. So that would be an alternative way of doing it, or you can use a set, and if it exists in the previous set, add it to a new set, and then replace the previous set with the new set. So this works as well, and it might be a little bit faster overall, but it shouldn't make a huge difference. And if you use map is also a tree map, so it should already be in sorted order as well. So for the final question, ICPC tutorial, this is based off of Big O notation, and it talks about when should you expect a solution to timeout, and when should you expect it to AC all clear, so accepted, all clear, whatever. And you have different time complexities, and you have the maximum number of operations you can do. You have the number of operations the computer used can run in 1 second is the first number, and then the second number is the largest n in the problem description, and then the third number is the time complexity of the algorithm. And so it's pretty simple overall. For example, let's say you have 10 to the power of 3, 6, 8, 10 to the power of 8, and you have 500, and then number 3 is n to the 4th. So 500 to the 4th, compare it against this first number. But where you start to have issues is overflow. So before we talk about that, the simplest way to organize this would be you only have 3 inputs with numbers, so input in the 3 numbers, and then I would probably use a switch statement and just use different functions. You can just use a bunch of functions, write a bunch of functions, and then this will clean up the code. I would definitely advise against writing everything within the block. That just gets really, really messy, so I'd probably just split it off into different functions. And then within the function, for stuff like linear, it's very easy. Just compare n and m, of course. And if you look at n log n, so the max value of n is going to be 10 to the power of 9. And log base 2 of 10 to the power of 9 is 30, around 30. So 30 times 10 to the power of 9 would be like 3 times 10 to the power of 10. And that fits within a long, so we don't have any issues working with 64-bit numbers. So you can just, for n log n, we can just do n times log base 2 of n, and in that maximum value, it'll still fit within the 64-bit integer. If you look at n squared, again, the largest value that n squared can be is 10 to the power of 9 squared, and you get 10 to the power of 18, which 10 to the power of 18 barely fits within a 64-bit integer, so you can just do a direct comparison here. But if you have n cubed, and n cubed is a little bit larger, so if you have n cubed and 10 to the power of 9, then it'll be like 10 to the power of 27. Yeah, 3 times 9, 27. So that will not fit within a 64-bit integer. So you do have to start doing like start with n, compare it with m or something, and then just multiply one at a time. And the reason you can do this is, let's say you have n is equal to 10 to the power of 8 or 10 to the power of 9 or something too big. Then if you square it, at that point it'll already be larger than the max. So that's why you can kind of square it first and compare it. If you cube it, I think I don't know, maybe there are edge cases where I didn't take too much time, but maybe there are edge cases where n cubed is larger than 10 to the power of 9, but in that case, it'll still fit within a long. So you can already cube it, and if it's barely larger than m, then that should still fit within a 64-bit integer, so never mind. It should work, but if you just directly go 10 to the power of if you go n to the 4th power and n to the 3rd power and stuff like that, it'll just grow really big really quickly, and it'll just be way too big. Same with exponential and factorial. You want to multiply the values one at a time, and just check if it's larger than m. And even like one step before being too large to fit within a 64-bit integer, it should already be larger than 10 to the power of 9, I think. So in general, that should work. So that's the trickiest part. The first part is, can you multiply? What does this mean? And just doing division, or just doing a comparison with the n value multiplied in these different ways and comparing it with m. That's the first part, and working with different cases. And then the second part is, if you look at the input, this input is not going to fit within a 64-bit integer, so what do you do? That's going to be the second part. So it's a multi-part. You do need to understand both parts of that to get a correct solution. So yeah, even if you figure out the first part, you'll still get a wrong answer if you don't make sure that your answers will work with the maximum case. So that's going to be the tricky part here. And that's it. Thanks for watching.